Okay, so today we're going to be looking at our second 6 weeks exam and a review on that. Now, if you remember, I told you last 6 weeks that we would be building on that material for this 6 weeks. So I'm going to spend some time reviewing some of the information from last 6 weeks, and ultimately it will show back up on this test. So for your benefit, you might really want to go back and look at the last 6 weeks review, so the first 6 weeks review on YouTube, and get a good and comfortable understanding of what we did there. Because some questions similar to last 6 weeks will also appear on this test, okay? So let's get started. Okay, first thing we want to do is know how to count our atoms. Each one of these items right here is a formula for a certain compound. And so the formula essentially means like H2O is a formula for water, NaCl is a formula for salt. So a formula basically is what atoms make up that particular compound to make it unique and whatever it happens to be. So it's not very important that we know what the formula is or the compound necessarily is, but we need to be able to know what the atoms are and how many of those atoms show up in the formula. So here we have Ba with parentheses NO2 or NO3 close parentheses and a 2. What this 2 right here is a subscript, meaning that it multiplies the number of atoms it's next to. Well, this 2 is next to the parentheses. So whatever is in the parentheses will be affected by that 2. The 3, however, is only next to the O right here. And so the O is only affected by that 3. But the 2, on the other hand, the subscript for the 2, is affecting the O and the N. The Ba is unaffected, okay? So how many atoms do we have here? Well, beryllium, we just have one atom. There's no subscript next to it, there's no coefficient, meaning a number in front, so there's only one atom of beryllium. Now, N, for nitrogen, is affected by this 2. So we have to multiply. Well, there's only one N, so N1 multiplied by 2 equals 2. So there are 2 nitrogen atoms. The O, on the other hand, the oxygen atom, has 3 of those. But that 3 is also affected by that 2, so that 3 multiplied times the 2 equals 6. So on the oxygen we have 6 atoms. So how many total atoms do we have in this compound? So we add the 6 plus the 2 plus the 1. So we have 9 total atoms. Now some questions, if you remember, say how many elements make up one molecule? Well, there's only 3 elements that make up a molecule. So if we were asked about how many elements make it up, there's only 3 elements. But if it asks you for atoms, you can count up the atoms and total them. Now let's do the same thing for this next compound. If you notice this next one, we have hydrogen, we have boron, and we have oxygen. Okay? The hydrogen is affected by this 3 right here. So this hydrogen, there are 3 atoms. Boron has no subscript, so there's only 1. And oxygen, oops, let's cancel out of that. Oxygen only has 3. So how many total atoms do we have in this compound? Well, we have 3 plus that 1, that makes it 4, plus this other 3. So we have a total of 7 atoms, okay? But how many total elements make up this molecule? Well, there's only 3 elements that make it up. So make sure in your questions on the exam you understand the wording. Is it asking you to find the number of atoms or how many elements? If it says elements, just count up how many you have. Also remember, if you have a two-letter situation where one's a capital letter and the other one's a lowercase letter, that's only one type of atom. If you have just one capital letter, like here, each one of those are separate atoms. Okay, so remember that. Go back and review our other videos about that. Okay, next one, balancing chemical equations. Okay, we actually have a video on YouTube for balancing chemical equations. So let's try to see how many we have. We have carbons, we have hydrogens, we have oxygens. So if you remember, the stuff on the left side of the arrow are the reactants. The stuff on the right side of the arrow are the products. So we should have the same types of atoms on the product side. So C, H, and O. Remember, they have to match up and the numbers have to be the same because of the law of conservation of mass, which simply says that atoms cannot be created, or matter cannot be created or destroyed, that it only changes form. Okay? So let's count up our carbons. Over here we just have one carbon, we have 4 hydrogens, and we have 2 oxygens. Okay? Over here we have 1 carbon, 2 oxygens here, and 2 here, because that coefficient affects the 2 and the H. So any number in front, remember, that's multiplying our molecules. So that means there's actually 4 hydrogens here, and there's 2 oxygens. So we got 2 and 2, so we have 4 oxygens, and hydrogens we have 4. So we are unbalanced here. So what I want to do is erase some of my little notes right here, and we're going to add some coefficients to try to balance this equation. Okay, remember, we cannot go down with our numbers, we can only go up. So my carbons match, my hydrogens match, my oxygens do not match. So what I want to do is try to get my oxygens to match up. Well, this one can't go down, so this one must go up. So if I put a 2 in front of here, 2 times 2 equals 4. So now I got 1 carbon on the other side, 4 hydrogens, 4 hydrogens, 4 oxygens, and then we have 4 oxygens here. So this one now balances. Okay? So on the test, you'll notice that it has blanks in front right here. So make sure that if you don't need to put a coefficient, make sure you understand that that's like there's a 1 sitting there. Okay? So the answer to this one, if this was multiple choice, your answer you'd be looking for, like, let's say multiple choice A said you wanted 1, 2, 1, 2. So those numbers as coefficients would balance this equation. So make sure you understand that in the test, okay? Okay, next one. Compounds are formed from valence electrons. This example is a water molecule, and covalent bonding is happening here. Covalent means they share electrons. So if you notice, the green electrons are actually the hydrogen's electrons right here. Now he's only got one energy shell. So basically, remember, those shells are what the electrons sit in. And remember the first shell, if you remember our rule from the first 6 weeks, 2 and 8. Atoms with only 1 ring want to have 2 electrons. So how does he get those 2 electrons? Well, he shares an electron here with oxygen, and so does this one. Okay? Well, oxygen, if you notice, has 1, 2, 3, 4, 5, 6 of its outer electrons, its valences. So it wants 2 more to equal 8. So how does it get those extra ones? Well, it borrows 1 from hydrogen, and this hydrogen borrows 1. So basically, they are sharing electrons to fill their energy rings. And so that makes them satisfied. We call that a covalent bond. So how are compounds made? By bonds. Those valence electrons form bonds. That's very important you know that. Not only that, sometimes we have atoms that give away or take electrons from each other, and that's also a type of bond. That's where all the energy comes from in these reactions. So when you feel an exothermic reaction when an item heats up, or an endothermic when it cools down, it's taking in or giving off energy. That's all a result of the bonds breaking or bonds forming with those electrons. So let's look at one other type of compound that forms, okay? So here's a salt molecule being formed, sodium chloride. So if you notice, sodium has 1 electron in its outer ring. What group would you figure that would be in? If you think it's group 1, you would be right. Remember, group 1 only has 1 energy, or 1 electron in its outer ring. This one right here has 2, 4, 6. It has 7 electrons in its outer ring. So what group would that be in? Do you remember? Remember, if we go further over on the chart, group 17. Group 17, we don't count the 1, so it's in group 7. Go back and look at our periodic table, and we'll also review that periodic table here in just a little bit anyway, okay? So this one wants to get rid of its electron to make it happy. This one would love to gain its electron. But if you remember, this one has an equal number of protons in the center, okay? So it has a balance, it's neutral. Well, this one does too. So if this one gives away an electron, now that means that sodium's going to have a positive 1 charge because one of the electrons left. The same thing goes here. He has an equal number of protons and electrons for chlorine. Well, if he gains an electron, that means he has an extra electron than protons, so he now becomes negative. Remember, we called positive ions cations, and we called negative ions anions. So what happens? Remember, opposites attract. So because these atoms are now oppositely charged, they become attracted to each other. So they have this tendency to want to stay together. We call this an ionic bond. How are they doing it? Through the electrons again. And the valence electrons are the ones that come into play, not the inner electrons. Okay? Okay, so how do we predict what this atom is? The answer is below this black little label right here. And so what we have to do is figure out, there's a few ways we could do that. This should be a neutral atom. And if you notice here, we got positives here. We have a positive here, positive here, positive here. So we have protons right here. Remember, our atomic number tells us our atom. So if I know it's got 1, 2, 3, 4 protons right here, okay? But look here, I think it might have a proton hidden, because here's electrons. 1, 2, 3, 4, 5, 6. So we have 6 electrons, and we have 1, 2, 3, 4 protons that I can see. Okay? And then we have a number of neutrons, okay? So let's take a look at our chart and see what that is. Let's go over here. So if we notice here, carbon's atomic number is 6. I think there's probably a proton that's probably hidden in that little jumble. But remember, we had 6 electrons, and this is a neutral atom. So maybe not the best choice to use on our review. It might be confusing for you. I know this is a neutral atom, so we got 2, 4, 6 electrons. So that's going to be a carbon atom. Okay, it's a carbon atom. Really and realistically, I don't think on the test you're going to have anything confusing like that. You would see 6, so we got 1, 2, 3, 4. You would actually see 2 more protons in the picture we would have on the test. So counting your protons is always the safest bet. But I knew this picture where we grabbed it from for this review, I knew it was carbon. And the electrons and protons need to match in a neutral atom. So maybe should have picked a better one for our review, but understand that if we're dealing with a neutral atom, the electrons will also be equal to the atomic number. Okay? Okay, difference between physical and chemical properties. Remember, physical properties are ways we can describe an atom. So it's density. So it's density, and I said atom, but really any kind of compound, how we can describe it. So its physical properties would be density, how close together are its atoms, whether or not it's a solid, a liquid, or a gas. Okay. Let's see, we can also describe its boiling point. So how hot does it get for it to boil? Even solids get to a boiling point, melting points. So its temperature that it's going to get to. Let's see, we could also look at its shape, its color, texture, size. So anything we can describe with our eyes, our hands, if we put it on a scale, anything we can describe it with, heat it up, all those things, boiling point, melting point, those are all physical properties of matter. Chemical properties, however, are a little bit more complicated. It's oxidation. Can it rust or not? Some other things would be its flammability. You know, can it catch fire? So if it's flammable or not, those are some things we want to look at. Oxidation, remember another name for oxidation is rusting. See, this is their reactivity with other items. So how do they react with other items? Remember, our groups on our periodic table will tell us the reactivity of atoms, how reactive they might be based on their valence electrons. Some other things over here in physical properties would also be whether they're magnetic or not, whether or not they can conduct, electricity, all those kind. If it can conduct electricity or heat, those are things. Whether or not it's a solid, liquid, or gas, we said. Whether it's a metal or non-metal, those are all physical properties. Physical properties generally take up the list. chemical properties are just, does it tarnish? So one of the chemical properties of silver is it tarnishes if it's left out. It starts to kind of oxidize in a way where it's actually called tarnishing. So some of those kinds of things. Over here we could also say malleability. We could say ductile. Those are all properties of metal, of course. And we could say malleable, ductile, it's luster. All these are physical properties. So the majority of your list would be physical properties. Chemical properties are in a reaction state. Okay. Okay, so our periodic table, just some quick reviews. Remember that our group numbers will tell us valence electrons. We cannot use that rule for these guys right here. But for 13 it's really 3, for 14 it's 4, 15 it's 5, 16 it's 6, 17 7, and 18 is 8, with the exception of helium. Remember, helium only has one energy ring, so it only has 2 electrons to fill it up. Okay? Why is group 18 so stable? Remember, they have all the valence electrons they need, so they do not react with one another or other atoms. Remember, our periods, we have 7 periods right here, and they go from left to right. They will tell us the number of energy rings an atom has. Okay? So that's real important to understand. Okay, the zigzag line, if you remember, the zigzag line here separates metals from nonmetals. All this stuff on the left side are metals, with the exception of hydrogen. Hydrogen's a gas. He only belongs there because he's got one energy ring and he's got one valence electron. The nonmetals are on this side. And remember, our metalloids have properties of metals and nonmetals. So they're kind of on opposite sides of the zigzag line. Aluminum is a metal, so he doesn't count as a metalloid. Okay? So don't forget that this 14, our atomic number, will tell me protons and electrons. Okay? That's how we determined that atom earlier. Our atomic mass, we round it and subtract our atomic number, and that equals neutrons. Okay, really would help you to go back and review some of the periodic table reviews we did in earlier YouTube videos. Please do that. Take some time looking over that. This is a really quick review. You really should spend some time, if you're having trouble with this, looking back on the other YouTube videos. Okay, so really, I just wanted to show you this close up. This 14 would tell me that silicon has 14 protons. Because it's neutral, it has 14 electrons. They're negative. To find my my atomic, or to find what's in the nucleus, basically we have protons and neutrons. So to find my neutrons, I would round that number to 28, subtract 14. That 14 is coming from here. So 28 minus 14 is 14 neutrons. Remember, neutrons have no charge. The nucleus of an atom just has protons and neutrons inside. Okay? The electrons go around the outside. Okay? So the mass of the atom is really just this nucleus. Protons and neutrons make up the mass. Okay? Remember, we do not count the electrons in the mass of an atom. Okay? Okay, so it's important that you review the videos from our past lessons for this test. One thing that's not in this review that I didn't put a slide in for is how to determine speed. Speed equals distance over time. So you just divide bottom into top. I think there's a question in the test that shows you a graph, and it's a constant speed, which means that if this is distance in meters, and this is time in seconds, for example, and let's say that it's traveling at, let's say it's 0 meters, 2 meters, 4, 6, 8, 10, and so on, and let's say that the time is also going to 4, 6, 8, 10, and we just capture a point right here. It's 4 and 4, and so 4 meters divided by 4 seconds equals 1 meter per second. Okay? Or if I gave you an equation that said, let's say that something is traveling for, I don't know, let's say 3 hours, and they traveled 90 miles. So if we want to find out how fast that car is traveling, we would simply put distance over time, so 90 over 3, and this is hours, not seconds, and this is also miles, okay? So 3 goes into 90 3 times, or 30 times, so it's going to be 30 miles per hour. 30 miles per hour, okay? So, let's see, some of the videos, let's see how to get to my website. So if you're challenged by that, you don't know how to get to my website or my YouTube channel, it's important you go to the YouTube channel because it shows all my videos. To get there, go to www.hpisd.net. Under middle school, click on faculty. And then once you're there, you'll see my name, Michael Hayes. Click on it. And once you get to that first page, you're going to see a link that says Mr. Hayes' YouTube channel. Click on that. It will actually take you to my channel that shows all my videos. And then once you're there, these are the videos that would really be beneficial to look at for this 6 weeks, okay? So, some things you want to look at is chemical formula and reaction exam review, chemical formula and reaction exam review questions, balancing chemical formulas, lights out lab, chalk it up, dropping out, warming up, color switch, physics on balanced forces, fun physics, first 6 weeks test review. Lots of videos you could be watching to help enhance your skills. So please don't neglect that. Take some time to watch them. Your test is next week, so I really hope that you get a lot out of this video. We'll see you later. Thank you.